Okay, now we move to chapter 2, nonlinear equations. Okay, the outline, we have the nonlinear equation, intermediate value theorems. First of all, what is nonlinear equations? Okay, as long as you have an equation which is not in the form of, okay, this is actually the linear equation. This one is the linear equation, which is y equal to mx plus c, where this is the x, this is the y. So this is a linear graph, y equal to mx plus c, where the m is the slope here. Okay, this is the m. Okay, c is the y-intercept. Means as long as the equation is not in the form of a straight line, okay, or the linear equation, then it will become non-linear equation. Okay, for example, you have, okay, x minus cos x equal to 0, or you have a quadratic equation, quadratic, which is polynomial of degree 2, which is 3x squared plus 2x plus 1 equal to 1, or you have the cubic equations. Okay, as you have learned in secondary school, you know how to solve this quadratic and cubic equation or find the root of your quadratic equation. Okay, it's either you can factor it, okay, but in this case you cannot factor. If you can factor, okay, your quadratic equation, then you can, from here you can find what is x number 1, x number 2. Okay, in this case, you cannot factor, right? But this one, 3x, 3x squared. Yeah, if possible, we get back 1 here. So in this case, we have to use the quadratic formula to find the root, which is actually the x is negative b plus minus square root b squared minus 4ac divided by 2a. So for quadratic equations is actually one type of nonlinear equation. You know, okay, the way to find the roots, okay, either you can factor it, then from here you can find the roots, or else you can use, okay, this formula to get the roots. Okay, and from graphical point of view, okay, you know, okay, let's say this is a quadratic equation. Let's say this is a y equal to ax squared plus bx plus c. Okay, the root is actually your y-intercept. Root is here. Sorry, x-intercept, not y-intercept. Y-intercept is here. This is y-intercept is c. Okay, this is actually the root. Means solve quadratic equation, which is one type of nonlinear equation, or mean the word is actually you solve non-linear equation or find the root. Okay, and the root is actually represent what? Represent your x-intercept. Okay, x-intercept happen when y equal to 0. So this is here. X-intercept is happen when y equal to 0. Okay, and in secondary school also, you know how to find the root of the cubic equation. Okay, first of all, you have to guess, okay, the first root first. Okay, let's say you may get this. Some you can guess maybe, let's say, whether x equal to negative 1. You plug in here whether you can get it equal to 0. If here, this one you try x equal to negative 1, so you have 4 times negative 1 cubed plus 3 times negative 1 is positive 1. This is 2. Okay, times negative 1 plus 1. Whether you can get 0. If you can get 0, then x equal to negative 1 is the root. So this one you have negative 4 plus 3 minus 2 plus 1. Okay, 4 minus 4, the answer is negative 2, not equal to 0. So x equal to negative 1 is not the root. So you have to guess, okay, one by one until you find the first root. Okay, once you get the first root, let's say your root is, let's say the root is x equal to let's say I put a b c, and let's say e let's say x equal to e is the root. Then you put it become x minus e is a factor, and then you take this cubic equation 4x cubed plus 3x squared plus 2x using long division. You take this cubic equation, divide by this factor, you'll find here the quadratic equation. This one you will have ax squared plus bx plus c, your quadratic equation. And then you use here, you find one factor, then you solving this quadratic equation, you get another two factor by here, then you can get 3 roots. So cubic, you have 3 roots. That's what you learn in secondary school. So this one is just give you an idea what is a non-linear equations. Non-linear equations. Okay, as long as the equation which is not straight line or which is not linear, then it's automatically become non-linear equation. Okay, and you know, okay, the way to solve quadratic cubic. Okay, and then, or you can use your scientific calculator quickly to get the root of your quadratics, cubic, okay, and you have the latest model, you can get up to the polynomial of degree 4. Show you using the this model is what I said during the class, the EX 570 EX the class week, and you can search the mode here the equation modes. You can solve simultaneous equation polynomial. Now you want to find the nonlinear equation of type quadratic, cubic, and later on quadratic polynomial of degree 4. This model can solve up to polynomial of degree 4. So first of all, degree 2, put it here, 3. Just input the coefficient of your cubic equation, 3, 2, 1. So you get the imaginary roots. Those who have MS, I suggest you to change to this model directly, because MS you may miss the imaginary roots. Because to view the imaginary root, you need to press the shift equal, and you won't see in the natural display like this. This is the second root. And here you notice you have the QR yellow color, so you press the shift QR, and then you double click here. It should link you to the website. So this one, because we have complex roots, that's why you cannot see which is the x-intercept complex root. And then skip with just AC. I'll give you the minimum value and so on. I need to look back. Polynomial of degree 3. Degree 3, let's say I put 4, 3, 2, 1. Just simply put the coefficient for your polynomial of degree 3 or cubic. This is a root. 1, 2, 3. So cubic, you should have 3 roots. Let's see the graph. So I give you the roots here, 3. Because we got the other two is complex, we cannot see this is a xy plane, this is in the real axis. So you can see only the first one, the first root here. Okay, so and this model is up to move back, polynomial. You can solve up to polynomial of degree 4. Okay, that's it. Just simply put 5, 4, 3, 2, 1 as a polynomial of degree 4. Okay, here. So degree 4, you should have 4 roots. 3, 4. So you have, okay, root number 4, complex, number 3, complex, number 2, complex, okay, number 1 also complex. That's why when you see, you won't touch, okay, the x, in the x-intercept. So we have, okay, all are complex. That's why we won't see the x-intercept because complex root. If you have an imaginary root, we will see should have 4 x-intercept there. Okay, so this is okay, roughly ideal. Okay, what is a nonlinear equation? What is solving nonlinear equation is actually finding the root of that nonlinear equation. So as long as the equation which is not linear, it will become, okay, nonlinear. Okay, and then here, just from here, if fx is a nonlinear equation, nonlinear function, then fx equal to 0 is a nonlinear equation. Okay, to find the root of the nonlinear equation, okay, revise back. Okay, if the fx, if fx is a nonlinear function, then fx equal to 0 is a nonlinear equation. Then to find the root of nonlinear equation or solve for nonlinear equation is find the value of x equal to the x asterisk such that the f asterisk here equal to 0. And you want to find what is the value of x. When you substitute back to the function, you will get it equal to 0. Or means, okay, what is the value of x so that your y equal to 0. Okay. If you can get the graph, then you can easily see is it actually the x-intercept. If not, okay, what is the x value when we plug in into the function fx, we'll get it equal to 0. Okay, graphical point of view, the root of nonlinear equation is the x-intercept. Okay, and then, okay, finding location of roots, okay, given fx equal to 0, okay, we can rewrite it to fx1 equal to fx2. Okay, for example, okay, we have the nonlinear equation x minus, okay, x minus cos x, right? Just now you know, okay, the nonlinear equation x minus cos x equal 0. Okay, this is non-linear equation. If functions, if I say non-linear function means fx equal x minus cos x. So function, you notice, okay, function. The input is a x, your output means fx actually equal to what? Y. When you input x, you get y. So this is function. If equation, you have a left-hand side equal to right-hand side. So this is non-linear equation. This one is non-linear function. Okay. In the beginning stage, let's say we don't have the software to plot the graph. Okay, just now I directly show you, you can get the quadratic K and the cubic K, the cubic graph, or the polynomial degree 4 graph from the scientific calculator, Casio scientific calculator of fx570 fx. class week. Okay, and then let's say if you don't have the calculator and we have the nonlinear equation x minus cos x equal to 0. Okay, so we cannot know what kind of graph like this. So what we can do is actually from x minus cos x equal to 0. Okay, from here we can rewrite it as x equal cos x. So here, from fx equal to 0, you can break it become fx1 equal to fx2. That's why x equal to cos x. So in this one, the fx1 is the x, the fx2 is the cos x. And then you sketch the graph of y equal to fx1. Then you sketch the graph of y equal to x and the graph of y equal to cos x. Okay, and the intersection of the y, okay, graph of y equal to x and y equal to cos x is the value of the x equal to the x star such that the fx star equal to 0. This is one way to find the location or the interval of the roots. Okay, so here you can sketch this is y, this is x. Okay, so this is your y equal to x. See, I just sketched the positive part. Okay, you know here pi over 2 y equal cos x. Cos pi over 2 is 0. Okay, this point is actually pi. Cos pi is negative 1. Okay, this value is negative 1. Cos 0 is 1. Okay, so my graph is not that accurate. Okay, this point is 3 pi over 2. Okay, this point is actually 2 pi. I just sketched the positive part. Okay, so now, okay, so from the graph of y equal to x, red color, y equal to cos x, represent the nonlinear equation x minus cos x equal to 0. Hence, okay, the intersection, which is here, so this is the x star, asterisk here. So the root is here. This is the root. So if we sketch, okay, we can just roughly know the root is contained from x0 up to, okay, because this point is x equal to pi over 2. So the root is inside the interval 0 to pi over 2. Okay, this is roughly locate the interval of the roots, okay, through, okay, break the nonlinear equation, become two functions. Okay, and then I think this one we already sketched it. This one. Okay, this is using Maple. Okay, this is using Maple software to plot it. Okay, later I will show you. Okay, and then if you cannot sketch, don't know how to sketch that two graph, you can also use the intermediate value theorem. Okay, which state that if fx is continuous in the interval AB, if fx is continuous in the interval AB and FB less than 0, or FA and FB are opposite side, then exists at least one, okay, root which is in the interval AB such that fx star equal to 0. Okay, just now from the graph, right? Just now from y equal to x, and then you know this is 0 to pi over 2. The root is here. Okay, so we can try to guess. Okay, for this one, let's say x minus cos x equal to 0. So your nonlinear function is fx equal to x minus cos x. So you can put f0. So f0 minus cos 0. Cos 0 is 1. So f0 you have negative 1. Okay, and then you can put any value. Let's say I put pi over 2, or you may put pi, or you may put 1. Any value, just guessing. Let's say I put pi over 2, then pi over 2 minus cos pi over 2. Cos pi over 2 is 0. So you have this one is positive. If you don't use pi over 2, you may use, let's say, pi. Also can. So pi minus cos pi. Cos pi is negative 1. So this value pi plus 1 still positive. This is positive. This one is positive. This is negative. So according to intermediate value theorem, you have f0. You want to choose f pi over 2. I want to choose pi or 1 or 2. Any number. You can just change it. Let's say pi minus cos 1, you calculate it. If this is positive, then according to the intermediate value theorem, f0, f pi over 2 or pi, you get positive times negative, so you get the result is negative, which is less than 0. Therefore, exists at least one root in the interval, at least one root in the interval from 0 to pi over 2. According to this intermediate value theorem, because f0 times f pi over 2, I use pi is negative, then at least there exists at least one root in the interval from 0 to pi over 2. But this Casio is actually correct. The intersection point here is actually from 0 to pi over 2, or you may put larger pi. So the root stay in the interval 0 to pi over 2. I'm going to erase to show you what we mean by at least. Let's do this first. Pause here. See here. This show only two cases. So FA, FB, this is positive, this is negative. So from positive go to negative, sure you pass through y equal to 0. That's why you have at least one root here. Another case, FA is negative, FB positive. So negative go up to positive, must passing through y equal to 0. So these two graphs show at least one root. If FA, FB negative, then you are guaranteed at least one root in the interval A to B. Why at least? Because you may go down and then let's say go up, go down, go up, and then let's say this is a B. So in this case, so you have one root here. So you may have another root because FA positive, FB negative, but you go down, up again, then down again, up again, and then this one, FB negative. So that's why you may have at least one root in the interval AB if FA, FB less than 0. So to do this one, you have, seen just now. You put, so negative, positive. So there's at least one root in the interval 0 to pi over 2 for the nonlinear equation x minus cos x equal to 0, according to the intermediate value theorem. So now we have shown you, actually shows you actually you have two ways. It's either you sketch, just now I show you, okay, either you sketch the nonlinear equation x minus cos x, you break it into, okay, two functions. Okay, let's show you whether you can show directly the two function in your calculator. This one table. Okay, I break just now the nonlinear equation x minus cos x into x equal cos x. So, and then this is a cos gradient. Okay. So starting, ending step, you may change it. Now this is a function. Okay. Okay, you can see here. Okay, here because I break x minus cos x equal to 0 become x equal cos x. Okay. Into two functions. Then I want to plot these two graphs simultaneously. So shift functions. Okay. You see this one. Okay. This is what, okay, just now I input into the table form, okay, table format, right here, table input, okay, fx, one is x, oh, I cannot write here, fx is y equal to x, gx is y equal to cos x, and then, okay, just scanning the QR code, so the blue color is y equal to cos x, the red color is y equal to x. So from here you can read, okay, the intersection of these two graphs give you the root of the nonlinear equation x minus cos x equal to 0, which is roughly in the interval 0 to 1, because you can read here 0 to 1. Okay, if I sketch just now, I use 0 to pi over 2, which is 1.57 something. Okay, because here, at this point, cos pi over 2 is 0, that's why I can read it from 0 to pi over 2. But this one, because you got clear scale. Just now, when we sketch, we know this point is pi over 2. That's why I said scale the root in the interval 0 to pi over 2. But using the software, they plot it, you can see clearer. Shorter range, which is 0 to 1. So what is this value? Okay. So I have shown you, okay, how to use table form, okay, to plot two simultaneous equations. Okay, how about if you want to plot only one? Only one, huh? Okay, then two. Let's see. So if it's just one, let's try. Minus cos. The second function, we delete it, make it become 0 because I just want one, directly one non-linear equation. Okay. Again, I scan the QR code. Okay. Okay, the blue because the second function, I put it gx equal to 0. So this is a graph of the nonlinear equation x minus cos x. Okay, the root is exactly in between 0 to 1. Okay, how about, okay, to use your calculator to solve directly your nonlinear equation. Okay, show you mode 1. So you have, actually in radian mode. Check here, the angle unit, radian, alpha, x minus cos alpha x. And then you want to solve this nonlinear equation to guess what is the correct value of the roots here. You just know intermediate value theorem of the graph is just roughly know it is in the interval 0 to 1 here. So what is a value? What is a exactly value for the x-intercept here? So you press the solve button is a yellow color, so you press a shift, solve. Okay. So this is the initial guess. If you put 5 too far from the root, it will take longer time. So let's say I put 1. So we'll take, okay, because it's quite near, so we'll faster. So the root is actually 0.7390. If I round it to, let's say, 4 decimal place, it will be 0.7391. Okay. So this is using your scientific calculator. Okay. Just now I promised you, okay, how to use your, show you how to use Mapper. And later on, show you how to use your Excel. Okay, for Mapper, I start to clear the memory. Okay, and then for plotting, I normally would like to call the plot to see all the variable functions. These are all the variable functions that you can call using the plot. Okay. Okay. If I want to plot only one, I plot x minus cos x. So put x of -3. Okay, up to you to play around with the interval there. So here is up to you to put, okay? But make sure finite number lah. So from here you can see the graph of x minus cos x is actually in the interval 0 to 1. Okay, how about if you want to plot, just now we break the x minus cos x become x equal cos x. We want to plot two graphs simultaneously in a plot. Huh? Then we plot so this show this one. The red color is y equal x. The blue color is y equal cos x. Okay, you can actually label it, but okay, I forgot the command. You may search yourself. Okay, and actually you can also directly solve, okay, obtain the root by using fsolve. Okay, equals 0, solving for x. So you get the root directly. Okay, if you don't have the Mapper software, okay, and you don't have this scientific this EX model, you don't have the Mapper, okay, don't worry, you still have Excel. Okay, for Excel, we put it, let's say X, and show you first of all, okay, two graph together, y1 equal x, y2 equal cos x. And let's say 0. So I better zoom it so you can see clearly. We first put the border. Okay. Okay, you see I just key in 0, 1 and I select these two cells. Okay, and the pattern is actually from 0 to 1, the increment is 1. Then I point to the right bottom cell. Okay, I get this little plus is actually stand for shortcut for copy. So when I drag, you have copy with a pattern with one increment 1 unit. The shortcut for you to copy. And then I want to key in, this is, okay, to key in formula in Excel equal. Okay, of course you cannot key in X, huh? It will give you error, not name. Okay, but don't worry, X is stored in here, cell B3. So click B3. Okay, you get here, and then again to copy it down, just drag. So you see, the formula will relatively change according to rule. Just now you key equal B3, yeah? When you copy it down, it becomes B4. Okay, it follows, means it will follow the pattern. Okay, now you key in, this is cos X equal cos for any function in Excel, open, close, like in Mapper also. So, but you cannot key in X, not like the Mapper. Then you copy it down. Okay, and actually, because this is two, okay, two simultaneous, then select, insert. Okay, I would like to sketch the graph. This one, scatter, and then with the line. So now you can see. The blue one, y1 is x. Okay, y2 equal to cos x. Okay, they are, okay, intercept in the interval 0 to 1. Okay, and then you have, let's say you want to sketch one graph only, x, then this is y, this is actually your x minus cos x. We have here 0, 1. So just put 5. So this is equal, the x here, minus cos. This is the x. Okay, and then, okay. So you can see also, here, f0 is -1, f1 is positive. That's why according to intermediate value theorem, okay, your y value change from negative to positive. So according to UK intermediate value theorem, it should pass, okay, y equal to 0 through some point in the interval 0 to 1. Okay, so now if you want to sketch to plot this graph, okay, f0 is -1, f1 is positive. So from negative go to positive, sure it pass through y equal to 0. So this is the root. Okay, how to get the root from Excel? Let's see. This is x. This is x minus cos x. Let's see. Okay, I can find the root. Actually, the root happen when x minus cos x equal to 0. So you want to know what is the cell here. Set the objective. Okay, this one. I want x minus cos x become a value of 0 by changing variable cell. Okay, I want to change this cell. Okay, and then I just solve. So you get this value 0.73908. Okay. Tally with your scientific calculator mapper. Publisher. Mean to turn on this solver, you go to File, Options, Add in. Excel add in, go. Check on this solver. Add in. Here. And then you turn on this solver. We want to set this x minus cos x equal to 0. Because the root happened when y equal to 0. So you want to set this y value equal to 0 by varying the x value. X initially I put 0. We will change the x here until it reach x minus cos x equal to 0. Then I don't have any constraint here. If you have constraint, then you can solve the linear programming problem. Then you just solve. That's why you get, this is a root, 0.73908. So I conclude back, in this chapter, we just, roughly have two ideas, which is introduced to you what is a nonlinear equation, as long as an equation which is not linear is straight line. And then, we introduce to you, how to get the location of the root using intermediate value theorem. If you don't know, how to sketch the graph, you can just roughly guess. If FA times FB you get negative, then there is a root in the interval, A to B. Or you can break the graph here, the x minus cos x, because you know how to plot y equal to x, y equal to cos x. So this one, you can break it, become with the x minus cos x. You break it, become y equal x, y equal cos x. Because it become x equal cos x. And then the intersection of that two nonlinear function will give you the root. So roughly you read it from the graph there. If I sketch, I know this is pi over 2. So I said the root is in the interval 0 to pi over 2. Or you may use your scientific calculator. Scientific calculator. That's what you send here. Use the table, table menu to tabulate the nonlinear equations. Then you see that when the y value change from positive to negative or negative to positive, sure there is a root in the interval. Because here negative to positive. So it is confirmed that at least one root in the interval 0 to 1. So this one you can use a table mode, key in the second function as 0. Or you can obtain these two functions in your scientific in the table mode, and also you can plot these two graphs simultaneously as I shown just now in the already here in the H. This is x minus cos x. This one. This is in the table mode, two function. This is second function becomes 0. This is here. This one is a polynomial degree 4, degree 3, degree 2. So I've shown you, either you use a mapper, your scientific calculator, this one, or you use Microsoft Excel. So with this, thank you for your attention.